we shall plan our next module. The next module includes another important data structure, it is called the stack. Stack has many applications in programming. Without using stack, in fact, you cannot implement many algorithms actually. So, today we have a basic idea about this stack structure, and at the end of this lecture, I will try to give some idea about its few application. And then we will, in this module, we also discussed in as a series, we can discuss about how the programming for stack using Java programming can be done, and also how the stack can be implemented using Java collection framework. So, this is the topic that we are going to cover. First, we will introduce the stack concept, and then how the stack can be stored in a memory. So, there are two ways, using array and using linked list, that we will cover quickly. And obviously, knowing a data structure means what are the different operations that can be possible. We will try the different operations on stack, and finally, try to understand about application of stacks. So, this is basically a plan for this video lecture. Now, let us come to the introduction, and then stack is basically very common in our daily life. For example, if you visit any restaurant, then you can give an order for different plates, and then the boy can serve you, and usually boy can stack the different plates. So, boy first place the stack this one containing some item, then next and so on. Now, when the boy will serve to the customer, so basically he will serve in opposite order the way he placed the item. So, this will given first, then next one and next one. So, this is basically the way the stack works for the restaurant people or boy. Now, here again loading and unloading a cargo basically follow the stack mechanism. So, basically you suppose load the car here in this cargo. So, if you load in this way, then while you are unloading, the unloading you will be see the last which was loaded will be unloaded first. Now, there is another example, that is the example where the different rail train coaches are to be inserted into the rail ears. So, this is the one train, this is another train and another train. So, if those trains are stacked into the rail ear, and then while these trains are moving, you can see the train which added into the rail ear last is basically removed first. Now, all this concept actually if you see, the concept is that last in first out. So, that is why the stack data structure is also alternatively called LIFO structure, because last in first out, the element which added at the end will be removed at the first actually. Now, let us see what is the official definition of the stack. Now, stack like array linked list, as we have learned about, is an order collection and also homogeneous, because a stack should includes only one type of data, not the different type. So, if you want to maintain a stack of integers, then only you can add integer value, but not the other type of value. So, that is why it is called the order collection, because the order is maintained. Order means in which order you add, in that order will be maintained. So, it is not the random order, and then it basically allow one of all operations not from anywhere like array or linked list. In case of array, you can insert anywhere, you can delete from anywhere. In case of linked list also you can do the same thing, but in case of array, your insertion should be at one place and deletion also from the same place. So, one n only. As an example, you can see if this is the stack there and this is the top, means this is the current location where the recent insertion takes place or deletion takes place. Now, if you go for further insertion, it is called the push in case of stack, or remove called the pop operation, then it will take place from there. In other words, if you want to insert item 3 delete item 3, you will not be able to do that, or if you want to insert some item after item 4, you cannot do that, it will be always insert here. So, this is why insertion deletion can be taken place at one place only. Now, if we do this, it basically satisfy LIFO property. LIFO property is ensured by allowing or by restricting insertion deletion of any other item or objects into the stack structure at one end only. Okay, so this is the definition of a stack. I hope you have understood about the concept of stack. Now let us see how a stack can be stored in a memory. There are two different ways the stack can be maintained. One usual way, this is little bit easy way you can say, is the array representation. What exactly the array representation is? So basically this is the array of elements, and here you can see there are two locations. This is the bottom and this is the top. That means array will grow from here only. So the first we shall add element into the 0th index or 1 index or L index, whatever it is there, and then if you want to add next item in this way. So if we go on adding elements, so a stack will grow in this direction. So stack go in this direction, and at any instant the topmost element is pointed by one pointer, it is called the top. So top indicates that which is the topmost element in the stack, and then stack can grow till it basically exhausted. That means exhausted means if the element come at this location and top is here, and if you want to add further, then you will not be able to, because in that case it is called the stack is overflow. Now, so this is the array representation. In case of array representation, as you know, size of the stack is limited. After some times if you go on adding, so it become overflow. So it is just some sort of static way the array the stack can be maintained. Alternative to this array, the linked list, as you know, linked list supports dynamic. You can go on adding as many as one. So there will be never stack overflow situation in case of array unless the memory is exhausted. So memory is exhausted means your memory bank is not able to supply to add a new node into your linked list. Now, so this way here again very pretty simple, as I told you that insertion or deletion, namely push and pop operation in case of stack it is called, they can be done only at one end. So this is basically at the front only. So top actually a pointer, it points to the first element in the list, and if you want to add it, it is basically insert front, and if you want to remove an element, it is basically delete end, delete front actually. So only two operations that is basically applicable for the linked list representation of stack is basically insert front and delete front, and this way you can maintain a stack. So this is the two broad ways of maintaining an array in a memory. It is called the array stack representation. Now let us learn about operations on stack. We have told that only two operations, major operations, those are possible, is called inserting an item into a stack and removing an item into a stack. And there are few more operations are also possible to know how many elements are there, what is the current size of the stack, whether stack is empty or not, and which is the element at the top without any popping we can, if we want to show. So these are the methods, these basically methods are called miscellaneous methods, which comes under the status operation. So mainly three categories of operation called push. Push is basically inserting an item into the stack, and removing an item basically called the pop, and status is basically to check the size, empty state, or many other things that you can think about it. Now, so let us see how the different operations can be implemented using each representation, namely array representation and linked list representation. First we shall discuss about array representation, and then we will come to the discussion of same thing but with linked list representation. Now the stack array representation is very simple. I have given an algorithm for you, and I assume that the maximum size of the stack is decided by the field, it is called the size. So stack will grow from 0 to size minus 1 or 1 to size, depending on whatever the way you want to index. So in case of Java it should be 0 to size minus 1. Now here is the method how we can add into the stack. In this case I assume that index is from 1 to size. So if top is greater than equal to size, so that means it reaches to the end, that means it is the stack overflow condition. So stack is full, otherwise it will just move the top into the next position and add the item into that position, and this completes the push operation in this case. So, this is basically how an item can be added into the stack. So, this basically gives a screenshot about how the push before stack and then after stack. As you can see, the stack grow in this direction, right, in this direction, starting from this is called the bottom of the stack, the first element of the stack, and this is the current location, and if you add one element, you see the top will be moved to this and current location will be stored here. So, this is a pretty simple so far array. You are basically adding some element, inserting some element into an array, and you can go on, you are able to do until array is not exhausted. So, this is the idea about how the push operation or insertion of an item into a stack using array can be done. Now, let us come to the another opposite operation is called pop. Pop is basically opposite to the push operation. Push operation add element, pop operation on the other hand remove element. Now, you can continue this removal until stack is empty. So, before going to push operation, it is your step is to check whether stack is empty or not, like before insertion you have to check whether stack is full or not. So, the starting statement that can be here if top less than 1. So, top less than 1 means it exceeds 1, I mean the bottom location. So, it goes there. So, in this case if top is here, this indicates that this stack is empty. Now, otherwise if top is less than this one, that means some elements are there, maybe top is here. So, if top is here, it will basically delete this element and then top will be moved to the next element. So, this will be the this one, for example here. So, this is the code here. First, if top is permissible so that stack is not empty, then we can read the element and then top can be decremented by 1 so that it can move to the next, it can point to the next item in the stack. So, this is a very pretty simple pop operation for a stack using array. Now, there is other operation like status. So, status operation is basically say whether stack is empty or if it is, what is the total number of elements present in there, what is the capacity size, like. So, here basically if you see if top less than 1, stack is empty status you can print, and if top greater than equals size you can say stack is full. So, empty and full you can write different other methods also, I mean operation, or in one operation you can do. In this example we have done all the things in one operation, called the operation is status. Now, here also you can see how many total, I mean available things is available there. So, you can see percentage calculation, so many things. These are pretty simple thing that you can do minimum calculation, that what is about the stack size and then capacity, availability, like this one. So, these are the 3 different methods, fundamental methods basically we need to have its application in many contexts. Anyway, application will be next discussion, we will consider first. Now, let us come to the discussion about stack with linked list representation, which is more, I mean advantageous than the array representation, because array representation suffers from memory, memory constant actually. That means you cannot go beyond certain size or whatever it is there, but linked list can go beyond size. I mean it does not depend on the size until the memory is exhausted. Memory means the actual memory where your program data everything is stored. Now, let us see how the array representation of the things. I told you that in case of linked list representation, the insertion and deletion, that means push and pop operation will takes place from the front only. So, here the push operation, the scenario how it will look like this. So, this is suppose the linked list at any instant, it can be empty of course. If it is not empty, let us see how the push operation can be done. As I told you, push operation should be, so this top actually indicates that which is the topmost element in the linked list. Now, if you want to add a new element, what exactly that, okay, this link is not correct, actually this is the mistake in this diagram, you should ignore this one. It basically so it basically, okay, new node, this is the new node obtained it, and this is the top, okay. So, this is the topmost element. So, the new node that can be there we can add into here, that is all, and then this pointer will be mentioned there. So, this way you can go on. So, it is just okay, we have already learned about how element, a new node can be added at the front of a linked list. That concept is there, and here is the programming code, you can follow it, how an element can be added into the linked list. We are already learned about the linked list, is insertion and everything, so we just follow the same thing here and again, no need to discuss in details about it actually. So, like push, the pop operation is like this also, and so this is basically the linked list given to you before pop. Top is basically the topmost element, then if you want to do the pop, the after pop actually is basically return this element, it is basically remove the first element, and then pointer will be point to this one. So, this is the usual practice, and if the list is empty, obviously if you perform pop, it basically shows underflow or stack is empty like this one, and a simple code it is mentioned here for your understanding. This is so simple that you do not require any further discussion. If you read it, you will be able to understand it. So, I do not want to spend time on this. Now, so we have learned about push and pop operations on the linked list. Similarly, the status also, whether it is empty or it is, there is no concept of full actually. So, we can understand whether it is empty or not, or what is the total number of elements present there or not, all those things you can have it from the stack actually. So, there is a code actually given, it is a pseudo code, it is a algorithmic level code, it is there just for an understanding about. I have given some idea about that how the code will look like, and this is the code just similar to the array also, but in this case it is using linked list only. So, if you are familiar to linked list, its operations, its performance, writing program for you, it will be very easy actually, and I should advise you to go on writing the program for stack also using linked list, but you will see exactly how better programming can be done in another video. Okay, so this is about stack representation. We have learned about two type of representation, array representation and linked list representation, and how the different operation for each representation can be done. Now, we will discuss about applications of stack. Now, these applications actually, that is why stack is so popular. Now, stack is so popular because there are many algorithms if you want to build develop for your application where the stack needs to be there. Now, there are many sorting algorithm, for example, or searching algorithm, or some calculation like factorial. In many situations you have to use stack, but one thing is that stack is so frequently occur on data structure, that is why many operating system or compiler, they have their own way of managing stack automatically without any headache of the programmer. This, for example, if you want to use a stack for your some calculation, say factorial calculation in a recursive, for any recursive programming, if you know, stack is the must. So, without any stack you can, but you have possibly you are familiar to many stack many methods which you declare using recursion, but in that case if you see, you did not use stack explicitly, rather implicitly you call method recursively, but whenever the recursive method is executed, then there is a runtime manager automatically maintain a stack and do the all operation like push pop of their own. So, at the back end actually stack is working actually, but we do not bother about it. This is the good things that support is given to the programmer actually. Anyway, but see, if we want to use it for some operation where you want to explicitly use stack, how it can be done. And before going to these things, I will list few major applications where the stack is extensively used. One used is that using arithmetic expression. In your program, you can write many arithmetic expression for your mathematical calculation or whatever it is there, and ever have you thought how compiler or runtime manager calculate your expression? Now, this is not an easy task that okay, an expression will be calculated so easily, but to do these things runtime manager consider a stack to follow it. Now, this is the one example. Next, recursive call, implementation, execution of a recursive function, there also the stack needs to be applied. For example, factorial calculation, quick sort, merge sort, then Tower of Hanoi problem, there are many GCD calculation, what is not, many methods we usually like to have it using recursion. So, that also you can see how the stack can be used to support your recursive call execution. Then scope rule implementation, this is one compiler issue. So, if you want to parse your programming language, and then in Java for example, there is a dynamic binding, static scope, dynamic scope, runtime polymorphism, so many things are basically implemented. Program, you go on writing the program, but runtime manager check that which scope rule should be binding to a particular object or variables or field, and then accordingly it will resolve it. So, this scope resolution is basically done by means of, that is called stack. In that case, that stack is called activation record management. Now, so there are many applications like, and finally the last but not least is the memory management. Now, memory management in many situations, it is again related to the compiler execution or system level programming, parsing or natural language processing or machine learning information processing. So, there you have to follow the stack actually. Now, I have listed only few, actually I could go on increasing more application in this category. Okay, anyway, these are the important application that you can I mean that we are usually doing it whenever a programmer has to develop application, maybe system application, system level application or application for a business organization, whatever it is there. Anyway, so in this lecture it is not possible to discuss all applications because time is short, but we can consider at least a very simple application. I will just discuss about evaluation of arithmetic expression quickly, but here we will see exactly in order to evaluate an arithmetic expression. So, there are two tasks actually. The first is that we have to convert the given expression into a specific notation. This is called the postfix notation, and then expression which we are familiar with, it is called the infix notation. So, basically the first step is that infix to postfix, then only we can go for calculating, evaluating an expression, and finally evaluation for a given value of a unknown or variables. Now, quickly we will discuss about arithmetic expression evaluation. Now, here is an example. First, let us see, this is typically an arithmetic expression look like. Now, why evaluation is not so easy? This is not easy because this expression is given to say 5 different students for the same values of a, b, c, d, e, f, g. You may find many results from the many student, and every student can claim that yeah, my calculation is correct. Actually, which result is correct? So, that is basically idea is that whenever you have to evaluate an expression, you have to consider two things about the operators there in the expression. Operator means here for example addition is an operator, multiplication, subtraction, division, exponential, these are the operation. Now, so these are the operators. Now, what is the problem so far an arithmetic expression evaluation is concerned is that all operators are not of equal precedence. What is the idea? If suppose a plus b star c it is given, then you should perform multiplication first, then come to the addition. So, this is called the precedence. So, if many operators are there, operations are to be done, then you have to do that operator which has the highest precedence. So, here I have listed the precedence of operation. As you can see, the different operator, logical operator, Boolean operator, arithmetic operator and XOR, they are basically low precedence actually, and here unary operator is the highest precedence, exponential operator is there. So, this basically lists the different order of precedence of the different operator, those are there usually available in arithmetic expression. Other than precedence, there is one is called associativity. Now, some calculation you have to do in left to right and something is right to left. Yeah. So, now usually if you see the many operator that we have mentioned, they are usually left to right calculation, but there are some operators is a right to left. For example, if I write, so e then exponential f then exponential again x, so e to the power f to the power x. Okay. So, it is like this. So, e to the power a f, then f to the power x. So, basically we have to first do it and then we have to do it. So, f to the power x should be calculated first, then we can come to the e to the power x. So, it is like 2 to the power m, then power n. So, m to the power n first, then 2 to the power m in m to the power n, it is like this. So, this is basically called the right to left. Now, here exponential operation you see right to left. On the other hand, actually this associativity usually coming into the picture to resolve if the operators are having the same precedence, but different operators. For example, if I write say A plus B minus C. Now, here you see the operators here plus and minus, they are of same precedence, but for plus and minus if you see they are basically left to right. This means that we have to calculate first A plus B, then you have to calculate the next one. So, basically left to right order we have to do the calculation. Now, so if you follow all these precedence rule and associativity rule in this expression, then only your calculation is there. In any order if you do the operation, then it may gives the wrong result for the same values. So, that is why 5 students can come with the different results, because they do not follow this associativity and precedence properly. Now, so this is the problem, that is why arithmetic evaluation expression is not an easy task or trivial task actually. Now, see how this can be done here. I have given some example here in which order the different expression is there, because it is the highest precedence. So, we have to first calculate this one. So, this is the first one and then this is the second one, and this is a different order that we can do it as it is shown there. So, this basically the order according to this associativity and precedence rule, for the same order it can be calculated, and if you follow this rule then it will give you the correct result. So, this way we have to have the mechanism, so that how the precedence and associativity should be followed while you are calculating or evaluating an arithmetic expression. Now, there are another way also, some expression can be parenthesized. If you the parenthesize, then you know all the innermost parenthesis should be calculated first. So, this kind of things if you want to overrule about the default precedence and associativity over the given an expression, it is like. So, this is an example here. What you can see, we have overruled the precedence by inserting this one. So, in that case, as you can see, these are the operations should be taken first, because these are the innermost. Then once it is done, then this operation will be taken first, and then this operation, and then finally this operation. So, in which order all these things are there, it is shown here. You can check it. So, if we have the forced parenthesis or expression is parenthesized, then parenthesis can also can tell you that in which order you should do the expression, evaluate the expression. So, that is why we have to have the mechanism, and this mechanism can be followed if we follow stack there. Now, in order to have the stack into there is basically check whether an operator should be followed according to this precedence and associativity. So, they are basically for different order here the programmer mathematician has defined two priorities called ISP, in stack priority, and ICP called incoming priority. So, for different symbols they have the different priority, it is decided empirically. So, you have to keep in your memory while you are calculating. So, here idea is basically that whenever we can pop and push, that decide by the in stack priority and incoming priority. If some item which we are going to have in our calculation, and whether we perform some operation or not, depending on in stack priority and incoming priority. So, there is a rule, and based on which rule an algorithm is basically designed, and then algorithm is mentioned here. This basically is an algorithm, shows you how you can convert an infixed expression to postfixed expression. Now, before going to this infixed and postfixed expression, I just want to have a quick discussion about what is the postfixed expression actually. Now, the postfixed expression is basically, as you see suppose A plus B, if it is the addition of two operand A plus B, and operator is basically in between the operand. So, that is why it is called the infix. The postfix operation is basically operator should be at the end of the operand. So, AB plus. So, this is the concept of the postfix. Now, here this is the expression in infix notation, and how you can convert into the postfix notation, and this is the postfix notation. As you see, all the operator those are there with the operand, they should go to the end. So, is a BC and then here BC minus D, this way it is like this one. Now, so this is basically one mechanism to be followed. Actually, the idea is that if the postfix operation is known to you, then calculating the value of an expression and using stack is far easier. So, that is why we have to do it. Okay, now let us come to the algorithm that we can think about how the this is an algorithm. I will not be able to discuss in details. You can take your own time to understand how this is pretty simple, when to do the push and when to do the pop. So, it depend on, it is like this. So, read a symbol from the expression. The symbol may be operator or operand or brackets, and then it basically either push or pop depending on that condition. So, if you follow this algorithm and write your code, you will be able to easily evaluate, convert an infix expression to postfix expression. I just okay, while I will do the programming, that time I will discuss about it, but I kept it pending for you to consult it in either any book, or you can follow these slides also, you can follow it. So, this algorithm is okay, as the time is little bit required. So, to understand this one. So, this is about the infix to postfix expression calculation. Now, as I can say that okay, so stack is used to here to follow the ordering of the different operator, or ensuring the precedence and associativity of the different operators in the expression calculation, and by virtue of push and pop operation. So, this is basically the main idea about it, and once the postfix expression is known to you, then you can write another algorithm where input will be postfix expression and then output will be the value of it, depending given the different values of the operator. So, this is an algorithm that again you can follow how the postfix expression can be evaluated for given set of values of the operand. So, this algorithm again I will not be able to discuss in details because it will take much time, but I advise you to go through the code. I mean every line you can follow. That means in which time we have to do the post, pop and push, it is basically the algorithm is written that way. So, this algorithm is very well exercised algorithm actually, and you can find this algorithm in many places and you can follow, and you can write the code accordingly following this algorithm. Once algorithm is known, then writing code is not the big job. So, you can follow and you can see that how it works there. Now, finally, the recursion implementation, and the recursion implementation, as I told you, the stack is required. Why the stack is required? Because this is a recursive method, recursive function. You can see how to calculate the factorial n sort of thing, this program. But here the implementation of this recursion is required because, as you see, in order to calculate 5 factorial, you have to complete 4 factorial. So, 5 factorial cannot be finished until 4 factorial. In order to 4 factorial calculation, so halfway completed calculation need to be stacked and then go for 4 factorial. Now, again 4 factorial means 3 factorial, and this way you have to go. Now, when you come to the 0 factorial means it is the termination, then we can just pop. So, this way actually go on pushing all the intermediate calculation, and then finally that popping, and finally you can get to the this one. So, push and pop are basically call of the different methods. Whenever you call a method, just go for pushing, and whenever the next way returning, I mean popping, so it will towards the final calculation. So, this basically idea is that you don't have, if you write a program following this algorithm, it will automatically use a stack, your runtime manager will do it. You do not have to use this stack and then push, pop and everything, but it is not your headache. So, for many calculations there, the system level, the stack already maintained by the operating system or runtime manager actually. Okay, so these are the few operations that we have discussed in this lecture. As it is not possible to discuss many other applications, I will suggest you to follow this book. This book has many applications, well exercised with illustration, and all algorithms are there. All algorithms obviously programming language independent way, Java, not necessarily written in Java, but you will be able to write the code following Java syntax and everything. So, this is the stack, and then okay, fine, we will discuss about stack programming in the next video lecture, where we can see how the stack can be implemented using Java programming language. Whatever the operation that we have mentioned using array or linked list can be understood. Okay, thank you very much.